I'm Sterling Perrin with Heavy Reading, and today I'm here with Helen Xenos from Ciena, and we are talking about something that's not AI, but still very exciting, IP over DWDM. So hi, welcome. Good to talk to you today, Helen.
Hey, Sterling. Nice to see you as always.
It is, and we're a busy show, ECOC 24, so lots of buzz around all things optics. Coherent pluggable optics, certainly a hot trend in the industry. We've been following it. We've done a lot with Ciena over the past couple of years. I know looking at Omdia data, 400ZR pluggables shipped in 2023 alone, over 250,000 modules. So great success story there. But Ciena's obviously very involved with pluggable optics. What are you seeing? What are you hearing from customers?
Yeah, so we've been shipping coherent pluggables for several years now, and absolutely very popular technology. I think one thing that may surprise people, or that's not known by many that just see the numbers, like these amazing numbers.
They're big numbers.
Yeah, they're huge numbers. The majority, vast majority, maybe 90+%, is actually, the pluggables are actually going to this very simple Metro DCI single span application. Very simple, sometimes handled by IMDD technology in the past. And so certainly very popular application, used wide scale deployments now of how these pluggables are used. There are less stories about, pluggables being deployed wide scale for general optical network type of architectures. And I guess that's why there's still a lot to talk about and why we have that webinar in October.
There is. We are, as you alluded to, we're working on an industry initiative project, working with OIF around making IP over DWDM a reality.
Yes.
The pluggables agree shipping very much into hyperscalers for DCI applications. What we're focusing on for the initiative is more traditional telecom architectures, which obviously are much more complex. And I would certainly agree with you, of course, that is much newer ground, a lot of complexity in there, a lot of challenges. So when we do the webinar, I'm sure there'll be a lot of discussion about what are the particular challenges about building an IP over DWDM architecture for these broader set of applications. What are you seeing? What kind of challenges do you encounter when you talk to your customer base about IP over DWDM?
So there's a lot of challenges that we've already overcome. So as an example, there are many interoperable transmission modes that have been implemented in plugs. We support them from a Ciena perspective today. And we've done line interrupt testing, and that has been successful. OIF has done multiple demos at events. We know that the pluggables with embedded amplification can work over different photonic line systems, so we've solved that problem. Mm-hmm. I think what I see as the biggest challenge right now is enabling this multi-vendor deployment model, where now we have these pluggables with these standard transmission modes, and our customers want to plug and play these pluggables into any of the routers, mm-hmm. and for it to just operate in a plug and play type of fashion. And we're still trying to figure out, there's some operational challenges that exist. Does every router support every transmission mode of every vendor's pluggable? Mm-hmm. No, we're not there right now. So that's one of the challenges. How does that management layer work? The CMIS, the OIF CMIS is great. It's the common management interface specification for communication between plug and host. That works quite well. What happens at the management layer? Can the management access all the information that's available from the coherent plug perspective from the router? And the answer is no right now. We're trying to solve these next level of challenges. At the IETF, who's also, trying to work very closely with the OIF as well. So we have a line view and a standard management approach moving forward. That's the number one topic actually, and challenge and discussion we're having with customers today.
Agreed. So you have the OIF, which is the plug to host management, doing very well. But then there's a kind of an upper layer of the network management, and that's where you see still a fair amount of work needs to be done to get it to where the even like I mentioned, the router being able to support any transmission mode on a plug. Yep.
The CMIS works fine. The router software has to be there to be able to support that.
Right.
So that might not always be there. And then if the router software doesn't support it, then any higher layer management system is not able to access that information either. So, I mean, all of these areas are kind of being worked to try to move forward and advance to wide-scale deployments, IP over DWDM, multi-vendor deployments.
Right. So there's a lot of neat hardware out there, and it just needs to be able to kind of operationalize it in the network. Speaking of neat hardware, you've got some stuff out here on the table. We are at ECOC 2024.
We are at ECOC.
An innovation showcase, one of the two big ones in optics. What's Ciena showing and doing?
So, well, we're showcasing our full range of 400 gig coherent pluggables. We have 400 ZR, 400 ZR Plus, embedded amplification, and we support the highest performance transmission mode in the industry, 70 gigabaud.
Okay.
That can go double the distance in 400 gig versus like a ZR Plus type mode.
So what, just kind of a benchmark, what kind of distance then would that be in there?
Well, we've tested in networks where you could see about, it depends on the network, but if you can see, let's say 500 kilometers, you can do 1,000 kilometers on 400 gigs with the plug, And we are also showcasing WaveLogic 6 Nano. That's our next generation. 3 nanometer CMOS ASIC. This is showing the design fitting into a QSFP-DD 800. So QSFP-DD, 400 gig. Now we have QSFP-DD, 800 gig. And now this one will support a lot of different transmission modes, including OIF compliant 800 ZR, 800 gig ZR Plus with interoperable PCS that can go 800 gig across 1,000 kilometer distances, other modes at 400 gig and 600 gig. Now, what's very interesting is we're also supporting in the 3 nanometer chip, 800 LR mode, which allows us to bring coherent technology into new applications. So campus and even data center fabric applications where we have never seen coherent before.
Right.
And what's new that we are announcing here at ECOC is that the chip actually supports 2x800 LR data paths. It also supports 8x224 gig SerDes lanes, as well as 1.6 terabit Ethernet from the client side, as well as 400 gig and 800 gig, which enables the 1.6T Coherent-Lite pluggable that now we can offer with WaveLogic 6 Nano 3 nanometer ASIC. This is a different design from the traditional coherent technology networking applications design. It's really power and latency optimized for these new shorter reach applications.
And again, the reach you're talking about
2 to 20 kilometers.
2 to 20 kilometers. So yeah, just a campus to even in the data center, but
in the data center, where we're seeing customers evaluating or deploying optical circuit switch type of architectures, or there's a lot of patch panels and loss that they have to deal with when they want to do. There's so many GPU to GPU connections that are being that they have to bring up.
Which kind of gets us into AI, which I said we were not going to talk about, but here we are.
We are not going to talk about that. Okay.
But applications is for it as well.
So applications that are driving the need for these types of solutions. How can you get most capacity, high capacity interconnect, smallest power footprint, but giving you the performance you need to address the requirements that they're seeing.
All right, lots going on. Great spending some time just learning about what's up with Ciena and working with you guys on the OIF project. So thanks for your insights.
Thank you, Sterling.
Thanks.
Always a pleasure.
Bye.